Hello everyone. Today we are talking about energy changes and we will introduce exothermic and endothermic reactions and processes. The main objectives of today's lesson are to be able to define energy changes and to distinguish between exothermic and endothermic reactions and processes. We will learn some important scientific terms such as system, surrounding, universe, exothermic and endothermic. So let's get started. Whenever chemicals react or a change in state takes place, we get a transfer of energy. This energy can be transferred in the form of heat energy, light energy, or even sound energy. Now, before we dig deeper into our lesson, we must understand two important concepts that will help us understand the energy changes occurring during our reaction or process. These two concepts are system and surrounding. The system is the specific part that contains the reaction or process you wish to study. System is the reactant particles. Surrounding, on the other hand, is everything other than your system, like the container around it, whether this container is just a tube or a beaker. Surrounding can be the water in an aqueous solution. System and surrounding make up the universe. So in this example representing magnesium ribbon reacting with hydrochloric acid in a test tube, the system is the particles of magnesium and hydrochloric acid, and the surrounding is the water, test tube, and the whole lab. We must take point of view of system, so we check if the system is losing heat energy or gaining it. But when it comes to temperature measurement, we measure temperature of surrounding using a thermometer. Now let's study these two cases. If a system during a reaction or a physical change is losing heat energy, here we say heat energy exits the system and is given out. As a result, temperature of the surrounding increases and thermometer reading rises. Here are some common examples of exothermic reactions and processes. We have combustion, acid-base neutralization, respiration, and freezing. In freezing, liquid water with high kinetic energy change to solid water with lower kinetic energy state. Here cooling is required, and the energy difference between liquid and solid is released. Temperature of surrounding increases. Now let's move to the second case, where system here is absorbing heat energy. Energy enters the system and is taken in. As a result, we will notice that in all endothermic reactions or processes, temperature of surrounding drops. These are some famous examples of endothermic reactions or processes. Notice that in all of these examples, energy must be supplied. We have photosynthesis, we have thermal decomposition, electrolysis, and melting. Now in melting process, solid particles with their low kinetic energy must gain energy to weaken intermolecular forces between them and to change to liquid particles with higher kinetic energy state. Here energy must be absorbed and the temperature of surrounding drops. Now here is the summary of exothermic reactions. Pause the video to study the summary and to write your own notes. Now we have the endothermic reaction summary. Pause the video to study the summary and to write your own notes. Now let's do a quick check to see if you are able to answer these questions. Now, is burning of magnesium ribbon exothermic or endothermic? You answered exo? Amazing. Now what about the process happening inside a cold pack to treat injury? Is it an endothermic or an exothermic? You answered endo? You are awesome. You can use the barcodes shown here to open links for more practice and for a practical investigation of endothermic and exothermic reactions. Thanks. Have a good day.